Right, so this is even more random than usual, but I'm over with Adrian at Carbon Wasp, Yorkshire carbon fibre producers, to have a look at their new truffle, full suspension frame, and also just kind of chat about where they came from, really, because it's just... Oh God! I nearly said relatable then, but it is. It's just a great kind of enthusiast, technologist, passion story, really. I guess. I've made it sound like Discovery Channel or something there, haven't I? But and apologies if this camera is pointing in entirely the wrong direction, because I've had to jump on the GoPro 7 because the GoPro 9 died this morning. Bless it, after well over a year of abuse. So quiet moment for the GoPro 9, and we'll see where we get to on the old 7. But anyway, I'm going to plonk it down in front of Chris. Sorry, not Chris. Chris is downstairs. Adrian, and we're going to go through the bits we've already talked about, because we've already covered a bit of ground, quickly, and then just a bit of chat, go and see the frame, go and see where it's made, and I think we're going in the woods, right?
Why not?
Yeah. So yeah, basically, started in a garage.
Yep.
As a hobby thing. I mean, you're an engineer.
Yeah.
And you're clearly just super interested in production and engineering and stuff like that.
Yeah, it's a fairly common story, isn't it? Like engineering bikers just want to make their own stuff, don't they?
Yeah. And then you started making your own frames out of alloy and
so it's like getting bits made, getting stuff machined, bought tubes, got it all welded, and it's in one-offs. It's prohibitively expensive, really. So I did some other stuff as well with a gearbox, but that's a whole other story. But
that's okay. That's a confessional for later.
So then this was, I don't know, maybe 15 years ago, a bit more.
Yeah, and then you started getting into composites.
Yeah, so a friend of mine kind of put me into composites, and then the thing about composites is you need tooling, so you need moulds. That's the only tricky bit. And so about the same time, I got into 3D printing, and so those two together create a really good process for low volume production.
Yeah. And like you say, it's a really good way to learn as well. Because you're literally, I mean, you were saying how if you were wet laying, you'd make a piece and then give it a bit of a flex and go, well, it's not stiff enough. And you can literally add, slap another couple of pieces on. Because if you're not familiar with how wet laying works, it's basically like when you're at school making a volcano out of papier-mâché.
It's exactly that, yeah.
You've got a bit of a mould or a mandrel or a shape you're making it on. And then you just literally slap in the high-tech version of wallpaper paste and newspaper.
That's it,
on.
And then you leave it overnight to cure room temperature.
Right.
It's messy, but it's crude. So carbon fibre has this kind of high-tech sort of mystique that we spoke about. But at a basic level, I mean, I made frames in a back bedroom in a flat that we had in the central Leeds,
Yeah.
You need a table, and that's it. I mean, we lost the breakage deposit, but that's something else. But,
you lost your bond?
Yeah.
Sorry.
But at the sort of entry level, it's a crude and accessible process.
And then you started making. Then people sort of caught on to what you were doing, and you started doing.
Yeah, I mean that was years and years later. So I went through. You start with the wet layup, which is dry fabric, wet resin, wet it out like your paper mâché, drape it on a mandrel and compress it somehow, and then forget about it for a day, and then that gives you a carbon part, and then you can move on and make more complicated parts, shapes. You can make so I made frames that way, or a frame, and it was awful. But then you learn about layup, like you say. You make you put you have a go at thinking about what you need, and then you can squish it.
Or maybe you put 45 degrees
flexible.
or 33
exactly.
degrees.
Yeah, so it gives you a really good understanding of how the material behaves that you can't get, I think, if you're buying in metal parts. Like you can.
Or some would argue you can't really get through FEA analysis on the computer and finite element analysis. You can see the colours change, but you haven't actually got an understanding. I remember speaking to Peter Denk, who's like, guru at carbon fibre with Scott and Cannondale and everything like that. And he was like in Taiwan in the proper early days, like in the 80s. Right. He did it as his university apprenticeship, basically.
Right.
That's when he started. And he said, carbon frame basically is only as good as the worst one you can make.
Yeah.
In terms of manufacturing, and it's very, and you need that knowledge to make a good one, really.
Yeah,
because you need to know, especially if, maybe not so much with you because you're hand producing them all, but at least you know which bits absolutely have to be right.
Yeah. I mean, that's the issue. I think consistency, isn't it? Because I guess metal parts, it's much more of a sort of industrial process, isn't it? You get tubes that are drawn a certain way, and you can be fairly consistent with that. And then machine parts, like yokes and all the rest of it, you can be fairly consistent with that because it comes off a machine, can't you? And then I guess you've got the welds then, haven't you? But
then you've also got the problem where if those parts start to slip out of tolerance or they're just made wrong, you just automatically go, oh, well, there you go. Well, it's the part. Right, hang on, where were we? Sorry, the old GoPro's overheating, but I think we've just got to the
carbon
fact that
frames. Yeah, I mean,
an alloy frame sometimes kind of leading you down a path.
Yeah.
If they're slightly out of tolerance.
True.
Because I've ridden bikes where they've gone, well, this is the down tube they gave me, so it must be this side, and you end up the Whistler on a major global brand launch with a freeride bike with a 73-degree head angle.
Right.
Or a full suspension bike with a 55-degree seat angle. Because, good old.
Yeah, I mean, carbon is, I'm not going to say it's easy, but you know what material you're putting in. You've got the tool that gives you the shape. As long as everything goes in, it's kind of, it's not hard to get consistency.
You can go back as well. I think you can add another layer.
Yeah, that's true.
I mean, it's maybe not the nicest cosmetic answer. But while you're making it, you can just you can literally just slap another piece on.
Yeah.
And immediately see the effect it has.
Yeah.
So it must be very rewarding to work with from that point of view.
Yeah, I think it is. And so doing it the sort of basic, crude ways, it does give you a really good understanding of what each bit of material does, and you can really get a good sense of the, like you say, put in something at 45 or 0.90, like the different orientations, the thicknesses you use, and where you put it. So as a kind of hands-on,
and you can read all that. And ad infinitum, but actually doing it, that's when it gets in your head.
Yeah, completely.
That's when you understand it. That's when you become fluent in it.
Yeah, I think
as a skill and as a knowledge, I guess. So.
And then you realise what was horrific about what you did, and you tweak the process. So you go from a wet layup to resin infusion, which is laying dry fabric in, and you wet resin. Same resin, well, similar wet room temperature curing resin is drawn through under a vacuum into the part.
So that's giving you a much more consistent part.
It's a dry process, and
a bit more efficient as well. Do you use less resin through that?
Yeah, so the whole point with composites is about the ratio of fibres to resin. So things like wet layup is really inconsistent. It's very difficult to get it right because you need to wet it out enough that it's wet.
Yeah, and the resin's the heavy bit.
Too much. Yeah, that's right. Yeah. So, I mean, not enough resin, you get dry patches, which is, you get voids, which is obviously huge weaknesses. Too much resin, extra weight, and gives you other problems. So, things like resin infusion, you start to get that. I mean, that's a fairly advanced technique, and they use it for a lot of commercial parts, outside, not bikes really, but that gets you that correct proportions, and the other way to do it, which we now use, is pre-preg. Where someone else measures the resin, mixes it all, and you know that it's your
carbon fibre ready meal.
Yeah, exactly. Yeah. So, but going through that process, you can appreciate that, and if you have a part, you get a dry patch where you didn't wet the fabric out enough, you can see it, and you can feel the weakness, and it's so. I spent years doing that, and like we said, there's a garage of horrors at my house.
But then you've got into repairing people's bikes.
Yeah, so
and then also subcontracting to other people as well. But I presume you must learn a lot from repairing other people's bikes.
Yeah, it's really useful. So we still do it. Yeah, and then we do loads of road bikes, and it's really interesting to see how they're made.
Because you're basically doing an autopsy each time, aren't you?
Kind of, yeah. So it's particularly interesting on things like bonding in inserts, so dropouts and bottom racket shells. And so it's useful to see how.
And is there a really wide range in what you're seeing?
Yeah.
Is it what people would hope? Is it sort of price specific? Are the cheaper ones cool? I'm not expecting you to name names here.
I don't.
It's not Hambini.
So, but I don't. No, it's fairly inconsistent, but it also goes with age. You can see a real sort of timeline of like older stuff that comes in. You can really see how even the same brand has improved.
Oh, that's good. I was
how
hoping you were
do
going to
stuff.
say
Yeah,
improved
yeah,
then,
yeah,
not
yeah.
got worse.
No, not got worse. No. But that's just the level of sort of understanding and technology, isn't it?
Yeah.
So yeah, we see a lot. So yeah, it's good to do that, and you can't tell everything from examining a carbon frame because you don't know about fibre orientation and things. But
And I guess you don't
can,
know the exact toe or anything like that.
No,
or fibre
but you
numbers
can
or the resins
kind of get an idea.
Yeah.
Like wall thicknesses, and you can often see if you know what you're looking for. You can see how things have been moulded and made, and you can like a lot of the older frames are just sort of cut and shut and bonded, aren't they? And you can see where that's done, and so that's useful, and we still do that. But also, I think it's kind of a good thing to do because it just there's no reason to scrap a carbon fibre bike frame really unless it's become unfashionable.
Yeah, because that's another thing. That's another misunderstanding about carbon. Is it is pretty much. I wouldn't say. Well, I guess as long as you don't care if it's that lucky, it's pretty infinite, isn't it? Yeah. Because UV degradation is not a thing anymore, is it?
No, especially if it's painted. I mean, most bikes are painted anyway.
Yeah.
So there's.
It is a triggers broom situation.
Yeah, exactly. Yeah. But why not? Yeah. Especially like a road bike. Like road bike geometry doesn't change that much. Like maybe tyre clearance has, hasn't it? But there's no real.
There's still plenty of people going. Actually, rim brakes have been fine for the past 100 years. I'm still all right. Actually.
Yeah. So
do you see? I mean, going back to while we're on the subject of like myths. Do you see a lot, is there a big difference between like high modulus frames, ultra high modulus and low modulus stuff?
I mean, no, because that's nonsense, isn't it?
The names are, normally.
Yeah. I mean, we use high modulus carbon, but you'd never make a whole part out of it because it's quite weak. High modulus is low strength. So you want, it's stiff, but it's brittle. Yeah. So you always have that mix, so yeah. I mean, we see some really good frames come in where you think they're really light and they are really stiff, and you think, that seems pretty good. Like road, I'm talking mainly in the repairs. It's mainly road frames because they are the way they're made. The way they get them so light is to make the tube so thin that we've had people who lean a top tube up against a bench and it buckles.
Wow.
But that's because it's less than a
they wanted a
millimetre
600 gram frame.
I know, yeah. So
and they're 90 kilos. Yeah.
Exactly, yeah. So that's
they're
the
going
thing,
down,
isn't it? Like,
go over cattle grids on butter tops. You're like, oh Lord, on a 300 gram fork. Yeah.
So there's a whole other issue there, isn't there, about longevity and
because carbon fibre, the way I understand it, it's either fine or it's YouTube. It's either fine or it's broken,
or it's not
really to a degree, or is that?
Yeah, it is. Yeah, on a sort of.
It's plastic and elastic deformation, isn't it?
Yeah. Once it's broken, it's broken. But
so is everything else. Actually, it probably tears better. Almost.
Yeah.
You're more likely to get, a progressive fail in carbon than you are with something like alloy and steel.
That's what I would say. Yeah. So you can often, like we get people in a lot of the time who just want a second opinion. And sometimes we see people and it's often there's no damage. Or you sort of say, well, there's a crack on your top tube or your seat stay, or there's visible, there's certainly damage, but it's not going to collapse.
Yeah.
So we'll fix it, but actually,
it's a Band-Aid.
Probably wouldn't say this, but you could probably ride it for 6 months and it's not going to, it's not going to be an issue. But
it's likely to crack somewhere else as it is there, kind of thing.
Yeah.
Whereas if that was an alloy or a steel crack,
it depends. That depends on the mode of failure, doesn't it? Because if there's an impact and you're unlikely to suffer the same impact, maybe you'll be all right. If it's a design flaw and a sort of some kind of fatigue thing, but we see very few of those really.
Right.
What we see in the vast majority of repairs is super thin, super light road frames that have had some kind of impact, a crash or something else that they're not designed to take. But the good news is you can fix it.
Yeah. Do many people snap the dropouts off on Zwift, or is that a myth?
Oh yeah, we've had a lot of that. Yeah. Turbos. Yeah.
Not surprised.
No.
Not surprised. People doing the dying duck act onto the ground afterwards. Like, oh. That's weird. Part of my bike's still in the stand. Yeah.
Yeah, we have.
Because again, that's something the bike isn't designed to handle at all, is it?
Exactly. Yeah. That's what it's about, isn't it? It's about carbon fibre. The best thing about it is you only need to put in the material you need.
When you can't do that within very specific vectors, if you want.
Yeah. And so if you're making a 600 gram road frame, you're going to be pretty narrow on what the design caseloads are, aren't you? So anything that's slightly outside that, and you'll have a problem. But why not make? Why not add a couple hundred grams? And I don't know. That's something else.
Well, I think most brands do, don't they?
Yeah.
I know people like Giant and stuff like that are very. I think interesting. It tends to be the ones who are really, really immersed in their carbon fibre construction.
Right.
Tend to just add a bit more, just in case. Well, and I think it's also changing the mountain bike thing when we were chatting earlier about like Santa Cruz doing a lifetime warranty.
Yeah.
It's like it's no surprise that a mega tower is bloody heavy.
Right.
Because you're offering a lifetime warranty on one of those, it's going to get properly rallied.
Yeah. But why not?
So
you
why
can.
not?
So,
You've now got a frame that you just go, go mad.
Yeah.
Go proper mad on it. And it'll survive. So how do you jump from? It's one thing I'm talking about. Jump from aero bar armrests, which is keeping you very busy, to building your own bike frame. Is this just kind of going back to your roots almost and just going,
so
I want a bike?
We've always been making bike frames.
Right,
we just haven't
there's a few
just
we'll go
been selling
downstairs
it.
and we'll have a look.
Yeah. This is kind of the first bike we're kind of launching. I mean, we've made an earlier version of this for the last couple of years.
I was going to say, I've been seeing it about.
We've never promoted it deliberately because we were never quite at the stage where we thought this is ready to go, if you know what I mean.
Yeah.
Like on a sort of consistent commercial basis, as in we can start knocking them out in some number. We've always made mountain bike frames because we're mountain bikers, really.
Yeah.
But it's just that we've never shouted about it until now. So, I mean, the first parts I made were bike frames, like all those years ago, and then it was about the actual bike design didn't really change significantly. It was just the process of making it. We went through, I don't know, a dozen ways of making it in a garage.
Yeah.
And then we came here a few years ago and started to move things on.
Like
and then, like you say, then we got, in some ways you could say we got distracted with other, like making bits for other people, but it paid the rent and we're still here. So I don't know.
It's giving you that glide height almost, giving you that altitude that you have got
so.
this bit
and
of
also
space.
the challenge. So what we were saying before about if you're only ever making your own stuff, you kind of play to your strengths, don't you? And you design things in a way that you know you can make. And I think it's useful to have people come at you and say, make this. And you're like, well...
Yeah, please rewrite this website copy with some more SEO words in it, please.
Yeah.
I mean, that's the phone call I had on the way over here, and that's the equivalent of my side
Same
of
thing.
things.
Yeah, exactly.
Well, I could say no, but what am I learning?
Yeah.
It's like, that's how Jack Kester writes about these bikes. It's just like, what an arse you'd be if you said that. And, you've got to take these things on. You've got to grow and you develop your skill. And I guess that's it. It's just like, oh, okay, right.
Yeah. So it's kind of, you're right. It's taking what you've already done, but applying it in a way that you hadn't thought of, and then see how you get on.
You go, okay, it's not quite what I'd have made, but I've made a fair fist of it.
Yeah.
And, you're happy with it, so there you go. We've all learned.
Yeah, I mean, out of that came a whole side of our sort of business. It's the track time trial triathlon side, which I did some time trials as a youngster, but I wouldn't, not really in that scene. We work with people who are.
Yeah.
But it's a good market there. The UK time trial scene is comparable, I think, to mountain bikes. We get the guys in. You must know them.
Probably more.
Yeah, and they're all tinkering with stuff, and there's nothing sort of stock on those bikes.
No,
everybody's got their own little...
I'd say it's far worse than mountain biking.
Yeah.
I think if you went to an evening 10, the amount of perversion and personalisation. Let's call it personalisation.
But it's great though, isn't it?
It's fabulous. Yeah.
As a mountain biker,
it's proper wacky races.
I kind of think we're the same. It's the same approach to a different problem. So it's good for us to be involved in that, I think, and it is.
But also in a weird way, it's almost more measurable on time trial stuff.
That's exactly what I think. Yeah, it is. So that's a really good application for carbon fibre, because one of the benefits of carbon fibre is you've got a clean sheet of paper with shapes.
Yeah.
So on a mountain bike frame, it's pretty good because you can put pivots where you want and you can make swoopy shapes, and that's great. But really, that's as far as it goes. It's kind of cosmetic.
Yeah.
The time trial stuff and the track, it's purely an aerodynamic game, isn't it?
And then if you don't get the UCI out of the question and put them on triathlon bikes, then it's like proper crazy season.
So you can make stuff for those guys that you just can't make out of metal. They don't have that conversation. It's not an issue. It's got to be carbon.
And also, because if you're making one-off armrests for people, you're not going to, order 50 of those in case another person, in case 49 other people kind of want the same thing.
Yeah. So that was good for us to be involved in, because it's interesting and it's challenging, but it's a really good use case for what we do. So.
And also, those things, I think what surprised people is how tough that stuff has to be as well.
Yeah.
I mean, I always remember speaking to the guy who made the Shiv bike for Specialized, Chris DeLucio, who's gone on to do all the aluminium stuff they've done, all the Smartwell stuff. His first project for Spec was building the Shiv.
Right.
When Cancellara moved from Cervelo to Specialized, and he said the hardest thing to build on that bike was the handlebars. Because Cancellara had it's the highest peak loading anywhere on a bike.
Right.
Is someone like him coming out of a corner, pulling on the bar and pressing down on the cranks on the opposite side. Yeah. It took him 4 months before he confessed that the 3T alloy bars they used to run were solid. They weighed the bars on a Shiv weigh more than the frame.
Oh, God,
and he was like, there was no other way we could do it, because it's got to be thin and flat and aero.
Well, we make some...
And also, it's pretty fail critical as well, especially for the Australian track team.
Yeah, I remember watching that. We make some drop handlebars for endurance events on the track for an Italian company, and I'll show you them downstairs because it's quite a good process we've got. Chris is going to make some. She's making some now, so we can go and look. But talking to those guys, and it's a totally different conversation to like mountain bikers or road riders. Even you talk to road riders about carbon fibre, and they think, oh yeah, you can get it down to 600 grams for my frame. It's all about weight, isn't it? But keeping the stiffness. Those track guys, it's all about shapes, and they don't care at all about weight. They want strength and stiffness. They need it to be reliable. Particularly, I mean, like bottom bracket area of a frame. Yeah, they need that to be super stiff to handle the load.
Yeah, the torque because they're coming off.
Weight
the blocks.
Weight is just so far down the list.
Well, it becomes an advantage. Irrelevant. Once you've accelerated, it almost becomes an advantage, doesn't it? I guess.
Yeah. So, so it's interesting to have that different approach, because then it makes you question things that you might take for granted in mountain bikes, for example. Yeah. So everybody talks about carbon fibre as being lighter weight, but maybe it doesn't have to be. It can be strong.
Maybe the fact that it's stronger, stiffer, repairable.
That's a different way of looking at it.
Hang on a minute, those all sound like good things to build a mountain bike out of.
You can make something the same strength that's lighter, or you can make something that's the same weight but stronger. It's, depending on what you want.
Well, they speak to most companies now, and their hardest thing. I mean, that's why Santa Cruz don't. Sorry, I keep going about Santa Cruz, but I just chat to their engineers a lot, and they don't make alloy apart from the Chameleon anymore because it's impossible to replicate. The metrics they can get without it just being either prohibitively expensive or prohibitively heavy. And you speak to the guys at Spec or the guys at Trek about putting a door in it.
Yes.
They're like, carbon, easy. You just easy. We just, like you say, you just put another. It's like getting a sticker when you had ring binders. You get your sticker around where the hole goes. Fine, sorted. On alloy, oh my lord.
Yes.
That's like 6 months of sweating over a small door on the frame. Reverse is like, frame's done. Can we get that little? No, not quite. That's where all the stress is blowing up. So interesting.
So it's got a lot of advantages, and there's a lot of misunderstanding. But to a large degree, it's what we said before. It suits a lot of people to keep that ignorance, doesn't it?
Yeah.
Because with that you can bump prices.
The Emperor's New Composites.
Yeah, exactly. Yeah. And it's the same with high modulus. like whatever,
Yeah,
call it what you like.
whatever,
but,
yeah.
Yeah.
Aerospace.
It gets you, gets you a good sticker, doesn't it? But,
Yeah.
otherwise, it doesn't mean anything. But.
Although I did see someone going on about recently about how it was the same carbon fibre was using that Boeing that kept falling out of the sky. I was like, you might want to refresh that copy there. But,
yeah.
And also, from your point of view, you're locally sourced as well, presume relatively locally sourced. I mean, where does your stuff come from?
Well,
I haven't asked you this beforehand, but now it's going to backfire on us, isn't it?
We buy all our pre-preg from the Midlands. So
well, I mean, that's a massive disappointment I can see to you as a Yorkshireman.
I know.
But you're not shipping, you're not looking at a picture of a boat in Shanghai going,
yeah, that's right. Yeah, I think ultimately they
up.
buy in the fibres.
Yeah.
And then they mix it up. They mix up the resin.
Yeah.
And then they produce it.
Because there aren't many people actually producing fibre, are there?
No. I think it all comes from Japan, doesn't it?
Yeah. It's all pretty much all Toray and Mitsubishi.
Yeah, but I suppose if you're shipping just tow, it's pretty high density.
Yeah.
So in terms of shipping costs,
it's
better than a bike frame or whatever.
Yeah,
it's super lightweight but bulky, isn't it? So yeah, you can ship a lot of tow in those containers. So yeah, they keep stock of that and mix it up, and then we just buy by the roll, and they do so the other thing with carbon is you get different weaves, different weights, different types of fibres that we said, different strengths and stiffnesses and things like that, and then it's about blending it to fit the end part you need and the process you're using. You know, in terms of like we use quite a thick, heavy fabric, and people talk about like I talk to customers about they don't want a heavy fabric because it's gonna make a heavy part. But it's not about that. It's about the end material thickness. So you've got you want a wall thickness of 1.5 millimeters, and you can get to that by using 10 thinner layers or 3 really thick layers.
Yeah, and so it's no different. I mean, it's like people getting dressed for a ride, isn't it? I mean, I guess that's the most relatable. That's the most relatable again. But it's like, well, you can wear 3 base layers. Yeah, or you can wear a slightly thicker one. It's the same result. Yeah, that's right. It's the same result. It depends.
But if you're on the clock dressing yourself, or you're in a rush, and you go for 1 thicker layer. Potentially that's...
And also, if it rains, that's going to keep you warmer. Or if it's windy, and that's going to stop the wind chill,
I think we've definitely stretched that as far as I can get.
I think literally.
Yeah, so that plays into your choice of fabrics as much as anything as well. How you're going to process it and things like that. Where you need the material, so you can use different... It gives you a lot of flexibility where... you need reinforcement, so you probably have like a basic layup for the whole part, and then you reinforce certain bits. So you can reinforce with unidirectional, which is fibres in one direction. So if you only need reinforcement in a certain way.
That's the silky looking stuff, if people are looking at it, whereas the cross-ply is the old 90s, I made a carbon fibre mountain bike
that's
stuff.
Right, but which is good for mountain bikes, because it's... you get better impact resistance and things like that.
Yeah, it's like ripstop in it. Again, going back to cloth, it's essentially your ripstop, isn't it?
Yeah. So, there's almost complete freedom from a design point of view and a manufacturing point of view, which is good and bad. It's it's great to have that because you can develop something in the way that you want, and it's applicable to your use case and all the rest of it. But bad because when you're staring at the abyss of all the choices,
make whatever you want,
an infinite choice. Exactly.
I don't know, love. You decide what we have for tea. Right. Well, that's probably a whole load of stuff at least there. Should we have a wander downstairs?
Yeah, let's do it.